Okay, let's get started. My name is Rebecca Wilson. I am the Marketing and Communications Manager at Copper Mountain Technologies. I wanted to tell you a couple things about the webinar before we get started. We will be recording it and sending it out, so you will get a copy of it after the completion of the webinar. If you do have any questions, you can find a Q&A tab next to the chat tab in the main area, or in the chat box, you can also find a little checkbox that says add to Q&A, and you can click that and add it to the Q&A section. The question and answers will be available to enter throughout the duration of the webinar. We will review any of the questions at the end of the webinar though. So welcome to our webinar today about simplifying IoT antenna testing and accelerating your product development. The purpose of this webinar is to provide an insight into how to evaluate your antenna performance, why it's important, and how to use the newest IoTest kit and software. We have Olivier Robin and Gregory Makar of Pulse Electronics today to speak with us, and I'll let Olivier get started.
Yes, do you hear me?
Yes.
Okay, very good. So hello everybody. So we're going to get started with the presentation of the IoTest kit. The kit is composed, so you can see a live video of Gregory in the lab there. So the box you see online on the video is the actual box. On the left side of the screen you see pictures of the box. So Gregory will easily make a description also as he's opening the box later on during the live demo. So inside the box you find an antenna analyzer powered by Copper Mountain Technologies. We call that device the P60. And there is also a calibration kit called the P911, and an RF cable with connectors, adapters for doing all the measurements you need for your IoT device, and 18 demo boards mounted with different antennas. There is on the box an indicator of which antenna demo board is working at what frequency, so that it's easier for you or your customer to pick up the right antenna demo board. So typically, an antenna demo board is a PCB on which you have an antenna SMT mounted and a connector SMA usually, where it's very easy to plug in and check the demo board and the characteristics of this antenna mounted on board. Next slide. So why did we design the IoTest kit? So we will show you that with that kit, you will be able to select, or your engineers or yourself will be able to select the proper antenna demo board that will match the frequency, the range of frequency that you need for your application. That demo board will be used as a reference board for your testing. Then we designed a great graphic user interface to simplify the usage of the VNA software. A lot of people in the IoT world are not a VNA user expert, and that's what we wanted to achieve with that kit. This kit, the software pops up automatically and guides you through the process of testing an antenna system, whether it is a demo board or your own IoT kit cabled. Then we will also, that kit will also guide you into how to test the antenna itself, whether it's yours or the demo board. It will guide you on to understand what you see with your own IoT device connected. And then it will also tell you when you need to calibrate or not the VNA, if you don't have the right background for RF testing. It's always good to have a reminder that when you change parameters on a VNA, sometimes you need to recalibrate. So those are the few points that you're going to get as a takeaway of this quick training. Why very often as Pulse Electronics is a main antenna player in the industry, and very often in the IoT world we are being asked, why do I need to test my antenna? You are selling those antennas off the shelf at distribution level, or even direct if you want to. You are telling us based on the data sheet that this antenna is great. Why do I need to test this antenna? And that's what we want. We want to easily prove the customer using the IoTest that not only there is a need to test the antenna once it's embedded in your device, but also this is the best way and a rapid way to make sure that your antenna is correctly tuned or matched in the device. So if you have to go through certification, you are already pre-assured that you're going to pass the test. So why is the antenna design important for your product? If your IoT antenna, if the antenna inside your device is not tuned at the right frequency, at the right impedance, compared to the radio source that you have on board or the radio module, you will create an impedance mismatch at the antenna feed. That device, the IoTest, will help you measure that device and how bad it is or how good it is based on the proper integration of your antenna in the device. So a return loss is then created, which is usually a negative number in dBs. And that number will help you understand how much power transmitted by the radio will be accepted by the antenna. And the more the antenna can accept, the more the antenna can radiate based on its efficiency. So therefore, the more the power the antenna can accept, the less battery drainage you will see, and the longer the device will last out in the field. So we are talking about a better budget link, and that's why it's very, very important to verify that the antenna tuning is correct in your device in the conditions that you want the device to be used. So the IoTest will allow you to perform all these tests. As we don't want to make that presentation too technical, but it's important to understand better why visually you need the IoTest to test your antenna. If you see on the left picture, we have put a radio block with an antenna impedance of 50 ohms, for example. The output impedance of the radio is 50 ohms. And you have an antenna connected to this radio. In the dashed red line is the plane in which we are measuring the antenna impedance. So whether it is your antenna or a demo board again. If that impedance is exactly equal or very close to the Z0, the output impedance of the radio, that just means that the reflection coefficient at the antenna input will be 0 or very close to, and therefore creates a return loss to be minus infinite in dB. So you will see a nice deep plot when you measure the return loss versus frequency, showing at what frequency the antenna is tuned the best. If somehow the impedance measured Z is different from Z0, then you have indeed power going back, being reflected to the radio, and therefore you will create a return loss that's not minus infinite. There will be a certain value in dB, and this is on the next slide how it looks like. So you see the gray in the vertical axis, you see the return loss in dB. In the horizontal axis, you see the frequency in megahertz, and the gray plot is a typical antenna response, return loss versus frequency for a tuned antenna. So what we are trying to show you here is that the IoTest will allow you within a minute to measure that plot and tell you exactly where the antenna will be the most efficient, where the antenna will be working the best, and verify that your antenna is tuned in the right frequency band corresponding to your application. So as an example, we are saying that the industry knows that a minus 10 dB return loss is good enough very often for an antenna. So if you manage to have the whole frequency bandwidth of your device below minus 10 dB, it is assumed that the antenna is good. The antenna is well tuned. And why is that? Minus 10 dB return loss more or less corresponds to less than 10% reflected power back to the radio. So the job of the antenna designer is to at least place the antenna bandwidths or the operating frequency band below minus 10 dB. So that will ensure that most of the power transmitted by the radio will be accepted by the antenna and most likely radiated in the air based on its efficiency. Now, what happens if you are on the complete left side of the plot or on the complete right side of the plot where the return loss is really, really low, close to zero? So as I said in a slide before, it would just mean that there is so much reflected power and so little power accepted by the antenna that the antenna will not be able to radiate in the air enough power to create a good budget link for your device. So this is put in very simple words that you want to make sure that you have all frequency bandwidths below minus 10 dB or very close to have a good antenna tuning for your application in your application, whether it is a device that is placed on animals, in water, or loaded with resin or with different surroundings. And the next slide explains, if the first two slides were a little bit too theoretical, we try to make it simple here by using the same picture on the left, so the DUT antenna connected to a radio, and on the right side you can imagine a base station antenna receiving the signal. And instead of speaking about impedance, we are talking about watts, power. So in the case one, we are saying here that imagining that the radio will send an output power of 1 watt over 915 megahertz, assuming the antenna impedance is very close to 50 ohm. Most of the power, so you will have a reflected coefficient of 0 because the impedance of the antenna is close to the output impedance of the radio. And therefore, the return loss will be minus infinite in dB. So that means all the power of the radio will be accepted by the antenna. So the 1 watt sent by the radio will be accepted by the antenna. And therefore, if the antenna efficiency is 100%, the 1 watt will be radiated completely in the air. Antenna efficiency is defined more or less by the structure of the antenna and the type of material we use to build that antenna. So usually you have conductive ohmic losses. You have different losses that impact the antenna efficiency. Very rarely it's 100%, but theoretically 100% antenna efficiency means that the antenna is perfect. Everything that comes in the antenna is radiated out. So if the antenna, now let's take the case number 2, if the antenna impedance, for example, is only 25 ohms instead of being 50 ohms, I calculated for you in advance that the return loss will be minus 9.5 dB, corresponding to a reflection coefficient of 0.33, which means that only 88% of the power will be accepted by the antenna. And as you recall, we had 1 watt at the input. We get 0.88 watts accepted by the antenna. And if, again, the antenna efficiency is 100%, then the full 0.88 watts will be radiated, which means that you have lost 0.12 watts because of the mismatch of your antenna inside the device. And that's why we want to make sure that all our customers have a tool to be able to measure those mismatch losses before they send the device into onto the field or into a certification for example, PTCRB or FCC. So why is the antenna design important for your frequency at the right impedance. Just to mention that the antenna design is not an afterthought. It is indeed easy to find antenna products today in the world with all the distribution partners that we have. And I will mention that later in the presentation. But the parameters that you see on a data sheet on a website are always, for antennas, are always different from real life, just because the antenna is a breathing element, if you wish, that is impacted by the surroundings. So antenna design is not black magic, as a lot of people want to make it believe, but it is all about managing the fields, the electromagnetic fields around the device, around the antenna, and only a few parameters allow to visualize those fields. And only a few tools allow you to characterize antennas the best way possible. Those tools are the IoTest or an anechoic chamber. And very often the antenna designer needs both tools to make sure that his antenna or antennas in the device will work perfectly. So here we summarized a little bit of all the things you can do with the P60 and the IoTest kit. So you will be able to verify the antenna tuning and if the impedance that your antenna has is the correct one to match the radio you plan to use, sorry. You will be able to see if the antenna has the right center frequency and the right bandwidth at the right location. You will be able to see if the matching is optimal or not. You will be able to see if the antenna is sensitive or not. And Gregory, in the live demo, will show you how we can do that. You will be able to see also sometimes you need to modify the PCB length or width to accommodate some clearance for the antenna, or to just present to the antenna enough ground so the antenna and the ground plane radiate together. So you will be able to see right away in a millisecond the impact of an extended PCB length or width on the antenna tuning. You will also be able to verify if the connection between your antenna and your device will be ideal or not. You will be able to very quickly verify if the acoustic components you have in your device, for example, speakers, microphones, earpieces, are choked or not, or need to be choked or not because they are too close to the antenna and will detune the antenna, not only by their amount of metal that they have inside each acoustic component, but also by the fact that they are fed by two power lines that sometimes have the right length to disturb the antenna efficiency. So you need to choke the lines very often, especially in small wearable devices. Sometimes you have wires in your device. You have other antennas, FPCs, displays, battery, shielding cans, cables. All these surroundings will disturb the antenna efficiency if they are not placed correctly in the device, or if the antenna is not far enough from those disruptors. So the P60 will be able to measure that impact directly on the return loss if you take into account the antenna tuning from the beginning of the design of your device. You will also be able to, as IoT is expanding very fast, you probably noticed that we are tracking animals, we are tracking devices on water, on boats. We are tracking a lot of devices today, and unfortunately, antennas are very sensitive to the loading that is presented to the device. So assuming your device has to be worn on bodies, so human bodies or animal bodies or anything that's not air, it could be a potting material for devices that are buried underground or under the asphalt. All this loading, additional loading, will detune your antenna, even if they are low loss. They have an epsilon R or decay that will impact the antenna tuning. You will be able, with the IoTest, to detect how bad or how good the loading around your antenna will disturb your matching. You will be able also sometimes a very simple location modification of the antenna will be able to go from bad to good. So with the P60, you can very easily move your antenna around in your device and see right away what position is better for the budget link you want to achieve. And of course, the last but not the least, the grounding inside your device is very often damaging, or could very often damage the matching of the antenna, especially during active testing. If you have to do TRP, TIS, or other types of active testing. So by modifying the ground on the spot, by either soldering shield cans or copper tape, you will be able to modify the currents leaking on the ground of the device, and therefore you will see that response on the return loss of the plot provided by the IoTest. So the IoTest kit is a very rapid way, is a tool that gives you a very rapid access to some measurements for detecting interferences around your antenna and making sure that if the next step for your device is to go on the field or in a certification stage, you will have the best antenna tuning you can on the spot. Next slide is about very typical questions that we get, just trying to understand how important it is to tune the antenna better. Very often we hear that the customer is telling us, I just need one more PCB spin to fine-tune the antenna tuning, and it's usually happening the week before the mass production. So if you have the IoTest, it's a good way to do something quick in the lab at your location. It's usually not if your management decided to kick off the product next week and your antenna tuning is not defined yet. You probably don't have time to talk to an antenna vendor and negotiate NRE or no NRE and find a way to get expertise at the last minute. This is probably not what you want to go against. So having a kit like that at home or in the lab is something very useful to for last tuning before the ramp up. Some people are telling us that to save money in the past, or because antenna tuning is black magic and they don't want to be disturbed by antenna engineers, they did the tuning themselves. And sometimes, unfortunately, when all goes good, it's fine. When all goes bad, then it's a never-ending story. So sometimes by doing the antenna tuning yourself without the proper tool or the proper skill sets, you might go to certification level FCC and then you fail the test. So problem is not only you lost money, but you lost time, and now you really need to fix the antenna tuning because you cannot launch your product. So and the next hurdle is the third-party test labs don't always have the time to accommodate a new set of testing the week after or the day after. So if you go and assist the tests, and with your kit, for example, you can be on the spot verifying that your device didn't suffer from transportation, or the kit is still working well in a passive way. And then when you plug it and give it to the technician, they can run the test. If you see an issue, you can debug it quickly on the spot and hopefully get your certification at the end of the day. We also here, as I said earlier, I bought this antenna off the shelf from a disti, and your antenna doesn't work according to the spec sheet. So what's going on? So usually they call our number 800 antenna. And our customer service would ask, okay, so where is your device installed? Is it on the ground, underwater? Is it in a potting material or not? Did you put the antenna layout as we recommended on the spec sheet? Is your PCB long enough, etc., etc.? So having a kit like the IoTest will help you debug your antenna tuning, even if you bought an off-the-shelf antenna. This kit is also very useful for Some of you are doing very big devices, very big. I'm going to use the example of a white good manufacturer who will build fridges or ovens, smart fridges, smart ovens, containers, metallic boxes for shielding whatever needs to be shielded. These customers do not want to ship you a prototype just for tuning the antenna. So again, either the field application engineer or the technical sales or the engineers that you have in your company can just go there and fix the tuning on the spot with the IoTest kit. Very mobile, very compact, very easy to carry on. If you are a startup or university and you have a limited budget for the antenna spending, again, that kit will answer a lot of questions from your buyer. It's a reasonable cost that we will talk about after. And again, it's mobile, compact. You don't need to have a full lab to use the IoTest. It, as you see, it fits on the table very easily. If somehow some of some of you, the customers, potential customers, have super confidential projects, very often as a supplier, we hear that, you know, even an NDA sometimes is not enough. We cannot share the device. We don't want to show you the box. We don't want to share the dimensions of the product. We are worried about the IP. So again, we strongly suggest to buy the IoTest. So even on a webinar, on a go-to meetings or WebEx type of conference call, we can assist the customer with its own. He will have his own IoTest. We have our own on our side, and we can help. We can assist the customer from a distance to be able to make sure that they connected the cable correctly, that they place the device the right way, that the conditions are ideal for an antenna testing. So again, you don't need, if you already work on confidential projects, you can have that IoTest at home or in the lab and make sure that you can do your own test very quick and very easily. So as a summary, the IoTest is, we believe, is very essential for a lot of IoT companies out there. It's a plug and play. It has a fantastic software that you're going to see the demo very soon by Greg. It's ideal for the sales teams on the fly, or the field application engineers that are traveling a lot and trying to debug antennas or RF for their customers. It's ideal for design houses. You can not only have a box full of antenna demos ready to be plugged and to perform basic testing, but also very easy to use and to connect to your device and understand how to test the antenna which is embedded in your device. Additional to that, we Pulse Electronics, we have 24/7 worldwide technical support, so we can help you. And I mentioned earlier, we have an 800 number, 800 antenna that you can call in any time, and we have a customer service in US to answer all your questions. Next slide. I talked about typical user case. So again, people who work at home, engineers who work at home, design houses, FAEs, technical sales. We also have a lot of system integrators who love this IoTest just because they can climb on top of the ladder or at the end of the pole and make sure the antenna is well tuned and well installed. Companies that who don't have the RF engineers or who don't have the skill sets, with this great software added on top of the VNA power, we can reach a larger crowd with who is not trained on how to use a VNA. So that GUI that we created makes it very easy to use for testing antennas. So if I would say a double E engineer or even a mechanical engineer with basic RF knowledge could use the IoTest to verify the antenna is well done or well tuned. Next, about the success stories. So I already mentioned a few, but this kit can help you do cable sanity check by measuring the VSWR. It can help you to do basic antenna testing on top of big devices. It can help you to measure the S parameters for confidential project if the nature of your business is such. It can help you to fine tune. For example, let's say you built devices that are supposed to be plugged in on a wall. As you know, the walls, the house walls can be drywalls, can be concrete, can be wood, can have metallic studs behind or not. So sometimes if you design a product that's supposed to be built on a wall, the antenna will be detuned based on what's behind that wall. And with the IoTest, you can easily access the antenna and verify that the tuning is still correct or not during the design phase. You can also, at Pulse Electronics, we also use that device for production. So we instead of using the old traditional massive VNAs from big brands that we all knew from 20 years ago, we use those small compact VNAs and we created mobile RF platforms for the production lines, so that once the technicians are done with building the antennas, they go around with the mobile platforms. It's a very compact system with a touchscreen monitor, and we test 100% of antennas coming out of any PulseLARSEN antenna factories. They are tested on return loss, and that device is very good for that purpose. Compact, again, mobile, and can go around very easily when you build a structure for that. Next, what are you going to learn today? Once Greg is done with the presentation, we will also share a few things on how to retune your antenna once you have seen that the antenna is not good enough. So obviously, the goal of the kit is not to teach people how to tune an antenna, but it's giving advices on what can you do very quickly after you have done the rapid test using the IoTest. So basically, you can move the antenna inside the device. You can optimize the matching circuit using capacitors and inductors. You can choose different antenna technology. So that means if you have access to those samples, to those typical antennas, but you have in a box, you can isolate the antenna from different surroundings by adding chokes. You can change or move the surroundings to eliminate interferences. You can modify the PCB or the grounding of the device, and you can modify the loading around the antenna. And again, Greg will show you what could be an impact of a loading on one device, for example. So we're going to talk about these things during the training. There is a link, PulseLARSENAntennas.com/IoTest kit. That link will give you access to the page with a price, with a data sheet, and the pictures of what it contains. So the link is here, and we will obviously, if you have any questions or if you lost that link, you can call us at 800 antennas. A quick word about Pulse Electronics. Just for those who don't know us, we are a 70-year-old company worldwide. The company has 8 business units. We are the ones in red here in the list, PulseLARSEN Antennas. In the world, we have about 6,000 employees. We are really all over the world, having factories all over the world in China, US, Europe, India. We have design centers across the world. So we are a well-established company. What does my company, PulseLARSEN Antennas, what are we interested in? What do we focus on today? We have 4 main segments. Transportation and vehicular is very big for us. Of course, IoT and anything that it includes, meaning smart homes, smart metering, smart cities, lighting, anything could more or less fall into IoT today. But those two first segments here, the blue and the red, are really strong within our company. And then we also do, on the side note, vehicular antennas, portable antennas for walkie-talkie type of antennas, infrastructure antennas, base station antennas, and we also involved in small cell carrier DAS and public safety DAS. So that's for a quick summary of what we do. And you will find online at many of the distribution partners that we have, and through our sales team and the channel we have, PulseLARSEN Antennas does 4 types of antennas. We do a lot of embedded solutions, which the kit introduces you to, as you have 18 demo boards of those embedded solutions inside the kit. We do cable assembly antennas, which are embedded in the device, but you connect them with a cable. We have outdoor or in-building antennas that can be still used for IoT, for traffic lights, or mounted on buildings. And we also do vehicular antennas that we call mobile antennas. So those antennas are big combo of antennas containing 2 to 6 antennas, usually having 2 4G antennas, 2 to 3 Wi-Fi antennas, and 1 GPS GNSS antenna on board. So this is for the presentation of the product. I am now done with the presentation, and I will hand over to Greg Makar for the live demo of the product and the software.
Thank you very much, Olivier. I am now going to share my screen so everyone can see my screen. It takes a little bit to load. If you weren't here earlier, it loaded very fast. I'm going to show you the IoTest kit real quick. I'm going to type in IoTest to launch this desktop software. While it's loading up, on the webcam, you'll see, here's the IoTest kit again. On the inside, immediately you'll see that P60 analyzer on top and the calibration kit. We need those to start using the kit immediately. Underneath this foam layer, there's a couple of cables before I make a mess right here in my work area. Let's move this over. Here's my analyzer again. You pull the black foam that the analyzer sits in. You can pull that right out of the blue foam in the case. And we're going to use this foam, in fact, later on for testing our antennas, and I'll explain why. I'm going to remove the cover for my P60 and set it there. This is the landing page for the IoTest software. You can see 3 main options: learn, measure, and optimize. The learn option has a couple of things for you. Firstly, it does include a list of all of the antennas that come in the kit, along with the applications they're used for, the particular parameters to them, what frequencies they work at. Data sheets are included there. So it'll help you maybe decide which antenna you're going to need for your product. The other thing the learn section will help you do, and we'll show why later, is it will help you make sure that your testing environment, the location that you're using, this P60 analyzer, is a good one, is going to give you accurate results. And we'll show you how that works, but you're going to compare your testing environment with the evaluation board's expected performance. So that's sort of the 2 things the learn section lets you do. The measure section is really what you're going to choose once you have an antenna selected, especially once you have that antenna on your board and you're measuring the performance on your own device. That measure section will allow you to more quickly get those responses from changes you're making to your board. So the measure section is great for when you want to test your antenna on your board and in real time get quick feedback on changes you're making. Lastly, the optimize section is there for when you've tuned the antenna yourself as far as you can go and you want to contact PulseLARSEN for that little bit of extra juice to get it perfect, or if you are very satisfied with what you're seeing in return loss and you want to contact us maybe about finding out chamber results, the final proof to yourself that the antenna is working fantastically. But since this is our first time using it, I'm going to select the Get Started option. The Get Started option will take me to a welcome section. And on the top here, we'll see, again, the Learn, Measure, and Optimize options, and a few others as well. So these are the sort of easy to navigate tabs that are on the software program. Firstly, we have an introduction about PulseLARSEN, about the kit. I'm going to use these arrows here to go through it forward and backwards throughout all of the different sections I'm in. It's really easy to use this software. So I just want to demonstrate that. So we'll go through this pretty quickly. The welcome section is really more useful once you're going to bought the program and are using it. The next step is registration. I will show you later why registering is important. For now, I'm going to move past it, but registering is important when you buy the product. Then this section tells you about antenna performance, why it matters, a couple things you can do to correct it. The fourth section gives an explanation for return loss. If somebody, of course, has purchased this program, they need to have a bit of an understanding of what they're measuring with the analyzer, and this will show them that. And finally, a little explanation about the antenna analyzer that Copper Mountain Technologies makes, this P60. So I'm going to click on the Learn tab and move straight into it. I want to spend some time, not too long, but some time talking about the features once again that I mentioned. The first thing you can do here is look at all of the antennas that are included in the kit, which is fantastic. They're all listed here. If you want to learn more about one of the antennas, click on this little I button next to it. You'll learn the features for the antenna, its applications. You'll also get to select datasheet if you want and open up the datasheet right on your computer. This is saved in the software when you install it, so you don't have to worry about having the internet. Or if you select more info, this gives you the opportunity to save onto your computer at a location of your choice things like the datasheet again, and also a 2D drawing for the antenna, a 3D model for the antenna if you want to try putting it on your device in a SolidWorks or otherwise program. So that's a great little piece that's included once again in the software. You don't need the internet for that, and it's very useful to many people. We have a lot of requests for the 3D diagrams. So that's one thing you can get looking at each antenna. You can find out a bit more about which one you want. You can also search through the antennas pretty simply up here. You can choose to narrow down the list. Maybe you want a dual band antenna. You can choose to do that here. I'm going to select all and type in 2400. Oops, that's 2400. And now I get an antenna that works at 2400 megahertz. You can also type in applications like GPS and get GPS antennas. So it's a great search option. And that's sort of the Learn section's first part when you're going to decide what antenna is going to be good for your application by going through the features of the antenna, what it works at frequency-wise, to determine what you're going to need, because you should have an idea of what application your device is going for. In this case, I'm going to select the W3010 for now. Once you've decided which antenna you're interested in using, hit the select button on the antenna. I'm going to double check real quick and make sure I'm in a nice visible, perfect. So the analyzer is visible. That's very good. The first thing it's going to tell me to do is to connect my USB cable to my analyzer. You'll see in the top left corner here, it says analyzer not ready. So the program recognizes it's not connected. There's my cable. I'm going to connect it to my analyzer. The Learn section leads you on in this very step-by-step. The Measure section has a lot, sort of skips over the step-by-step things, assuming you already know how to do it. I'd like to connect my USB cable to my computer. It recognizes it. Hit next. And now I'm going to connect my RF cable to my antenna analyzer. And you'll note it just popped up saying analyzer ready, little green box there, green in the top corner. So I know my analyzer is connected and has power. So tightening the nut on the analyzer to protect the threads. Oops. Perfect. My analyzer is ready to go. There's also a green light on the analyzer telling me it's on. I'm going to select next. Now I'm going to calibrate the antenna analyzer. This is very important to always calibrate your antenna analyzer whenever you're using it, especially when you switch frequency ranges if you're using it for more than one thing. This is what tells the antenna analyzer where to consider the end of its 50 ohm transmission line as described in the presentation. So this calibration is very critical to make sure you get accurate results from that point on, so we can measure return loss from this point on, because of course everything radiates. So it's important for it to establish a point at this is where I should recognize the beginning of where I need to measure power loss, that kind of thing. So I'm going to take my calibrator. I'm actually source it. So it explains a little bit about the calibration process. I should hit the next button. It tells you first you connect the open. I've just done that. I've connected the open. All 3 ports are labeled. There are 3 ports to the calibrator. I've clicked my open port right here. I'm going to select next. The 3 ports are open, short, and load. Sort of generally open, short, load is the order in which people do it. And it's the order we recommend based on convention. Here's short. And here's load. The calibration process takes a little bit of time, but any RF engineer will tell you it's critical to making sure your measurements are accurate. Now I'll hit next. If you've made a mistake along the way, you can go backwards to correct it. You can hit the red X button to restart your calibration at any time. I'm going to hit the green check mark to say that I've calibrated it correctly. Okay. So now I see a couple things. First, you see this black line that's moving up and down and a little sort of different shading color underneath that black line. That's what the analyzer is measuring. So we want to see that black line move with the antenna. You'll currently see a sort of gray shaded region here. This is what the Learn section offers best. It gives you an opportunity to determine if your setup matches the evaluation board's expected performance. That shaded line is a memory trace telling you this is what we expect, or what you should see, hopefully, if you're measuring in a good environment. I'll explain a little bit about that. This black foam here is used to lift the antenna a little farther off whatever surface I'm measuring it on. Antennas are very sensitive to all sorts of materials around them. Wood, not so much as others being bad, but especially if you have metal nearby or metal on your table, you want to get the antenna as far away from it as possible. That's part of what this black foam offers and why I recommend using it with these evaluation boards to make sure you're getting a better test environment. And this will allow me to see how good a test environment I have here. And once I've pulled my hand away from that antenna, you'll see it actually matches the memory trace very well. The black line here matches up that gray shadow on the back very well. That's great to see. That means that I'm measuring in a good environment. This is a fine place to measure my GPS antenna in this case. Remember, this is a GPS antenna. In fact, it's so far down on the return loss plot, it's a little hard to see that it's measuring at 1.57 gigahertz, 1.575 GPS. Scroll a little bit here, make it a little easier to see. You can see it's also reading it as excellent. Perfect. It's reading it as an excellent response. Negative 44 decibels for my peak resonance is excellent. That's far more than 99% of my power is getting through. This antenna, in fact, is actually designed not just for GPS, but for a larger band. You'll see here these red out-of-band areas. These are where we are not looking for performance. This is not what the antenna is designed for. This whole white band that goes up farther, closer to 1.61 gigahertz, includes other navigation system formats besides GPS, such as, for example, GLONASS. So if you're using it for another navigation system besides GPS, this antenna is actually designed for it as well. But so I want to also show you one thing. Olivier mentioned in the presentation about you can see if your antenna is sensitive. If I put my hand near it, we're going to see it respond immediately. That shows that it's radiating and it is sensitive. We can tell that because of the fact that it reacts to my hand. If I put my hand over here, in fact, I've even managed to make it, the resonant response now is in fact so far shifted in frequency due to the location of my hand that it's out of band. And you see that message there, out of band tuning needed. So what's happening is the antenna is still resonant at a frequency. The problem is the frequency at which you're getting all your power through, where your power is not reflected back to your radio, is one that we don't want to use, and that's important. You want to make sure the power gets through from your radio to your antenna and radiated at the frequency of your choice, because the receiver's expecting it at that frequency. In this location, without my hand in the way, you can see that it's radiating exactly where we expect it to, and this is a GPS. So this is good to see. This means that I've used the Learn section to determine I can measure my antenna in this environment, on this bench, in this location. Do it on your own bench in your lab. Find out if there's reflective surfaces nearby that are making it difficult to measure there. That's sort of what this is for. If I hit the next button, it'll give me some more information about characteristics of good antenna response. That's nice to see. You can tell it gives you a couple ideas of what might be giving you poor response if it's not the actual measurement. Troubleshooting ideas as well. So it's always possible sometimes that it's not in fact the antenna that's having issues, but there's a connection problem. Lastly, it gives you our contact information to get support from us. There's an advanced settings option beneath that. I'll get to that a little bit more in the measure section. That's essentially what the learn section is for, is finding out what antenna you wanted. If you wanted a GPS antenna, this would be a great choice, and making sure that you can test your device on your test bench, in your lab, wherever you are, and then you'll get the correct response. That your response you're seeing is not due to something else besides the antenna's poor, if that's the issue, performance. So I'll go to the measure section now. And again, I mentioned that this is a section for once you've actually tested your device. If you don't have your antenna or your analyzer connected, the screen will be loading. It won't actually show you a trace, but because we've already connected our antenna analyzer, it's loaded up here. I'm going to once again select the GPS antenna for now, just to show you a couple more things. We've chosen the 3010. Now, you should always calibrate every time you select an antenna measurement. In this case, in the principle of time, I'm going to show you calibration on a couple later steps. But so you can see, again, the very good response here of this antenna. If you go through the steps here, if you've chosen measure because you've just loaded the program, it's going to tell you to connect your test setup without giving you the same pictures and step-by-step of the previous learn section. It's just going to explain how to connect it again on the left there. It's going to tell you to calibrate your antenna analyzer, and you'll see the blinking calibrate antenna analyzer button. This is red. It says uncalibrated because it recognizes I haven't calibrated since I've switched to measure. It's going to tell you to connect the antenna and then to view the antenna's performance. So you can still go left and right on these blue options to more easily follow the steps, but the measure section does a lot less hand holding because it expects that you've already learned how to use the software and using the learn section. And once again, how to get support is included. And this time I do want to click on advanced settings. These advanced settings allow you to see a bit more on your software use than just what's immediately obvious. You'll note first maybe that the measure section doesn't include automatically the resonance memory trace that was there before. You'll see that the shaded gray area is all just the antenna response. There's not a memory trace to compare with the evaluation board's expected performance. You can select to turn that on here, and now you can see that memory trace saved. You can also decide if you don't want to see out-of-band shading to remove it. If you are not particularly interested in the moment at just the resonance tracking marker, but are also interested in the band edges, if I select here, these markers show up at the edges of the band. And again, GPS is narrow, but this antenna, in fact, can be used for other global navigation systems as well. I can select marker labels as well, and I can see the response, the return loss response at those locations, the band edges. In fact, it's greater than negative 10 decibels in both cases, so we know that more than 90% of the power is getting to the antenna at all frequencies that are in the navigation system collection. So it's very nice to see. So these are sort of the advanced settings you can access if you'd like when you're looking at your antenna. A bit more information than just the immediate return loss resonance point. You can get the band edges too, which can be quite helpful in a lot of cases. You can see my number of sweep points can be changed. You don't have a particular reason to do that in most cases, so you probably won't want to change that. It also confuses the memory trace if you are using the memory trace, so we don't recommend it. I'll leave that back on. There's one more option, show antenna analyzer. I'll show you that a little bit later. First, I want to show you what I mean by testing your own IoT device. I'm going to remove this evaluation board now. I have here the customer device. I won't go into the details, and you can see that it's a bit covered up because we do care about confidentiality. This device is using the 2.4 gigahertz W3108. I'm going to select, tell us about your antenna, the W3108. Now, I certainly need to calibrate in this case because I've changed the frequency I'm looking at. So whenever you do that, you want to calibrate. And you might see that the black line is not directly at the 0 dB mark. So I'm connecting the open port now. I'm going to select Calibrate Antenna Analyzer. You can see it's a much simpler screen this time. Connect open. Connect short. Because in this case, it expects that you learned how to calibrate in the learn section. You probably should always use the learn section before using the measure section to make sure you understand the software, even if you know how to use an antenna analyzer. and connect the load section. And apply. So now it's calibrated for this frequency range, which is 2.4 to 2.5 gigahertz. Connect my antenna. And move my hand. And you see a beautiful resonance, once again, 40 dB here at 2.43 gigahertz right in the band. So this is what you will do with your device, is connect it and see if you are in fact resonating in the band of interest. If you are making sure power is getting to the antenna from the radio instead of the energy being reflected back, that signal being sent along a transmission line to your radio. If it's reflected back, or from your radio, sorry, to your antenna, if it's reflected back to the radio, you're not actually radiating that power, it's being wasted. So this is very important to do these changes and see the response immediately. I want to show you one more thing, one more device, and show you why it matters so much. And of course, the tape does affect the performance a little bit, unfortunately, but it's important that we don't show you the actual customer device. This other device I want to show you because it will show you why it's important to consider your end environment, the end environment your antenna is performing in. This one uses the W3113 right here, which is a 915 megahertz ISM band antenna. Once again, I've changed my frequency range. I'm going to calibrate my analyzer. You get pretty used to doing this if you do RF engineering. But of course, if you're doing your own measurements on your your antenna in your IoT project, you probably aren't switching around. You probably have selected your antenna, so you don't need to calibrate every time you measure it. You just leave the antenna analyzer calibrated to the frequency that you're using. Connect to my short. And connect my load. Excuse me. So now I've calibrated to the 915 megahertz ISM band. You'll see the out of band shading next to it. I'm going to connect my device. And what you should see, in fact, is that it says out of band tuning needed. Well, why is that if I've selected the 915 megahertz device and this is the 915 megahertz antenna? It's because we had to tune the antenna to the customer's desired application. When we say tune, what that means is do something to affect where the resonance occurs frequency-wise, or to try to improve that resonance to make sure that more power is getting through to the antenna instead of being reflected back. So in this case, we had to change the frequency at which it resonated because of the material the antenna will be located in. I'll show you how that matters. I have here a container of that material. I can't show you what that material is, but what I will do is put my antenna device deeper into that material. Oops. And because it's a little bit of height, it's lifting my analyzer. I'll hold it there. Now you'll see resonance within the 915 megahertz ISM band. That's perfect. That's what we wanted to see, because it does matter that that material that the antenna is located in shifts and detunes the antenna from its original performance location. So it's very important to keep that in mind when you're doing your testing. I'll include here markers and marker labels. See the band edges there. We're seeing 9.6 dB. It's almost at 10 dB, so it's about 90% of power getting through at one edge of it, and 17 dB at the other band edge. So it's excellent radiation or return loss performance across the whole band, so we can expect radiation to be good at all those frequencies. So that's sort of why it matters when you're doing measuring to keep in mind what your test environment at the end of the day, what your performance environment for the antenna is going to be, where it needs to be functioning. So take that out. Now I mentioned I wanted to show one more thing, which was the show antenna analyzer option. If you are in fact an experienced RF engineer with VNAs, if you have used vector network analyzers before and know them well, the return loss that we see here, this measurement will help everybody determine if their antenna is going to perform well by just letting them know if their power is getting to the antenna, if they are radiating with energy. If the signal isn't getting to the antenna because it's being reflected back, you're not going to have good radiation. So this is an excellent way to determine whether or not you can expect good performance out of your antenna. If you want to get a bit more out of the analyzer and you understand how to use them, you can select the Show Antenna Analyzer option, and this will pop up, which is the actual analyzer software running. It does the same thing as the IoTest software. You can see it reacting to my hand here. See that line here reacting. This is a memory trace for the 915 megahertz antenna. It's sort of loaded in already in the state file of this software. This does everything that any other analyzer software does. You can export the data here. You can get S files if you know what those are here. You can do all sorts of things with it. You can look at the Smith chart here. You can look at SWR if you want to see that instead. And that's all a bunch of stuff that if you're an experienced RF engineer, you'll understand. If you aren't, that's fine. Use it for return loss, and that will do the job for you until perhaps you get to the optimizing section. That's why we're going to talk about that next. If you are done using this analyzer software, instead of exiting it out, which will confuse the IoTest software since it is using that background software, just click Show Antenna Analyzer again, and it will disappear off your bar there. So the last thing I want to show, well, the last big thing I want to show is the optimized section that I talked about earlier. This section essentially tells you the services PulseLARSEN can offer once you have determined that your return loss is excellent across your band of interest. If it's, your antenna seems to be getting the power from the radio across the whole band, or the resonant frequency you're interested in. We offer all sorts of passive tests. We offer active tests. So this section is for when you want to have us perhaps do an anechoic chamber measurement for you, so you can see the radiation efficiency, so you can see the total radiated power, the total isotropic sensitivity. These things that let you determine for sure, so you know with confidence you're going to pass PTCRB certification. The return loss gets you a lot of the way there. These ones finalize that for you. They give you the direct measurements that the same certification tests take, so you can see that, oh yeah, they should get these measurements too, which are passing measurements. These values are good enough. What this section also includes is a Register Now button. I'm going to click that now. I didn't click it earlier. It's very important that you register with us, the software, your name, please, your email address, and the company you're working for, so that we know, firstly, who has it, so that we know how to help you best. Without registering, we won't be able to assist you with this optimizing section with maybe suggested examples for how to tune your antenna because it's resonating at a different frequency than you want, because you want to improve that resonance, get a little bit better return loss there. This optimized section is very important for that. This registration section. Please register with us so that we know that, so that we can help you. If at any time, for some reason or another, it's very unexpected, something goes wrong, if we need to troubleshoot and help you out, we need the registration to be able to do that. So it's very important to register with us. Usually that welcome section is a great time to register, but the optimized section has it to remind you if you haven't done it yet, and if you want to talk to us about helping do that final tuning. That final tuning on our end sometimes means choosing an inductor, a capacitor. These are elements that when they're on the board affect the frequency resonance, affect return loss. It might be looking at length or something of the board. So these are things we look at when we come to tuning. Incorporates a whole lot of things. It's not necessarily a quick and easy process or a simple process. It takes some thinking. But when you're doing your own tuning in your lab, in the measure section, you can see immediately results based on what you're doing. There's two other tabs. I'll go over them briefly. There's a resources tab, which includes some presentations to give you more information about antennas. This gives you basic information about antennas, how they radiate, what that means, what the different parameters like efficiency mean. It gives you this one more information about how the ceramic chip antennas, a lot of these embedded antennas like the GPS 3010 that I showed you, the W3010, how they work, what they do. So this is just some helpful topics you might want to read over if you have the software. And lastly, there's a brief Q&A section to give you some tips if you have a couple of questions. How do I determine the antenna's frequency range? What specifications of an antenna are critical? Very important, how do I test an embedded antenna inside the device I'm designing? I'm not able to show you the boards of the two IoTest devices that I showed you again. I can't show you the board itself. But here you can see a cable is taken. You disconnect the feed line to the antenna from the radio trace to the antenna by cutting it, cut the copper line there so that the signal cannot travel along it. And then you connect your cable. It'll be a coax cable with an inner and an outer conductor. Inner conductor will be connected to this trace as close to the antenna as possible. The outer conductor will be soldered to the ground around it. And this will allow you to test your antenna on the board. So this is how somebody goes about and actually does a test on their own device using this analyzer. You get a cable on your device board, cut the trace so the signal can't go back to the radio, which will change your measurements, and it sends the signal from the analyzer to the trace itself. A couple things this kit includes that we didn't get to show before. It includes a couple of adapters. In fact, they're here on the bottom here. You might not be using a embedded antenna. Maybe you've chosen to use a flexible printed circuit antenna. I've got a very popular one here for ISM bands, the 3312. Maybe you want to use a LTE and GPS flexible antenna. The kit comes with an adapter for that, a UFL adapter, very common for these antennas. And SMA to SMA, comes with a right angle adapter as well. So it comes with some adapters for some further uses. If you're using an antenna such as this, and it's not located in the kit repertoire, in the antenna options here, under measure, you can choose, I have my own antenna, and select the frequency range you're interested in. Maybe I'm interested in 902 megahertz to 928 megahertz, the same ISM band I mentioned earlier. It will set up for you a band of resonance there of whether you're expecting to see good performance in the white band, the out of band, red bands. It'll set up where your resonance point is. So this is very useful if you have a different antenna, not just included in the kit. If you want to use one of our flexible antennas, that's certainly an option. We have adapters for it as well. So you can test these antennas as well without having to rely only on evaluation kit antennas. We have many fantastic antenna options. I believe that concludes my demonstration of the software.
Great. Okay, so we have one question, Gregory and Olivier. It says, is it possible to save or recall calibration data?
If you are a more experienced user with the vector network analyzer, and one moment please, I'm going to drink a little bit of water. Excuse me. If you are more experienced and can use the vector network analyzer software that Copper Mountain Technologies makes for their P60s, you can save calibration files here, save and recall them on your own computer. The IoTest software is meant to be a simpler form, easier to use, and doesn't include that itself. This will allow you to choose again pretty quickly the frequencies you're interested in, and you can calibrate pretty quickly. If you want to save a state, you'll want to use the software for the P60 itself from Copper Mountain Technologies, and it has all of those options you'd expect to find in a vector network analyzer. The IoTest software itself is meant to be much simpler, much cleaner, and easier to use for somebody with less experience. Hopefully that answers your question.
Yes.
Does anyone else have any other questions? I haven't seen any more pop through. We can give it a minute or two if you guys have any questions. If you don't have any questions, but you think of one later, of course, we can give the contact information so you can reach out to Pulse. Olivier, would you like to jump back into the presentation now?
Yes. So we have one more slide to cover. Thank you, Greg. How much, and where do you get the kits from? So again, we have a PulseLARSENAntennas.com IoTest kit page where you can get all this information. The price we offer is below $10,000 for the kit. That includes the whole box, of course, the P60, the Cal kit, the different adapters, cable, and all the demo boards. We have 10 kits available, ready to go right now from the US. So if you're located in US, you can get it in a day, more or less, or two, depending on what forwarder we use. We are not using distribution for that kit for now, so we are selling direct. Again, you can call us at 800 antenna you will get a customer service team there picking up your order. If somehow the demand is flying, the demand of the kit is flying very fast, we will have a 6 weeks lead time to send you a new kit or additional kits to your destination. We have also a second package, which we quote for less than $14,000. And that package is done for helping your first time dealing with antennas for your IoT device. So basically what we throw in here is 6 hours of engineering support if you buy that kit. So you get our field application engineer helping you out, making the best PCB layout possible, doing a report, testing your prototype, getting a full 3D anechoic chamber measurements in a facility in Vancouver, Washington. Okay, not Canada, but Vancouver, Washington, in Washington State. We have chambers, we have the full lab, the workshop, so we can actually help you during those 6 hours to debug most of the problems you might have in your product. If your product is already ready to go, if somehow you are at the early stage of the design, we will tell you what are the best conditions for the antenna implementation, and that's it. So again, two pricing: one $10,000 pricing for the kit itself, and a $14,000 pricing for including 6 hours engineering support. And on these 6 hours of engineering support, again, we are flexible. It could be debugging, it could be simulation software use, it could be surrounding improvements for your antenna, and it could be real measurements in the chamber after cabling your prototype if you decide to send us a prototype. We could build up a mock-up for you too if you are at the early stage of the design. We let the engineering support envelope wide enough, so because the IoT is a big, is covering so many topics and so many cases that it's impossible to generalize what customers might need. And that would conclude the presentation of the kit. So we are open for questions again.
I haven't seen any more questions pop through. You guys have another minute or so to put them through.
And what I can do here too is I can write my email here if you want to receive a quote, or if you want to receive the data sheet, if you don't have time, if you don't have access to Wi-Fi right away, if you want to get the slides, you can send me an email at orobin@pulseelectronics.com, and I will forward you right away information to show your buyer or to show whoever in your company if you feel like you need that kit.
Great. Okay, so it looks like we haven't had any more questions pop through. Just a reminder that you guys will get, oh, as soon as I said that, I saw that. What is the frequency range of the device?
Greg?
So if the guess means the analyzer itself, the analyzer can measure anywhere from 1 megahertz to 6 gigahertz. That's what the analyzer is designed for, 1 megahertz to 6 gigahertz. So nearly all the regular IoT applications at the moment. Certainly your Bluetooth, your cellular, Wi-Fi, other options like that, ISM bands. In the kit, the antennas range from as low as 313 megahertz, which is an ISM antenna, up to the 5.9 gigahertz, near the 6 gigahertz limit, which is a Wi-Fi antenna that includes the upper band of Wi-Fi. So those are the frequency range of the device and the frequency range of the antennas in the kit. And like Olivier did, I'm going to include my email here. It's Gregory Makar, which is Makar, @pulseelectronics.com. You can email me if you have any questions further about how the analyzer works, how the software works.
If I may add, on the website, on this PulseLARSENAntennas.com/IoTest kit, we also list all the antenna demo boards and all the frequencies they cover. So you can click on the plus button and you will see the exhaustive list of all the demo boards included.
Okay, so again, just to remind you, we will send out the recording once it is processed from Big Marker. I want to thank you guys for showing up and listening today, and Olivier and Gregory, thank you for some great content.
Thank you all.
All right, everyone have a great day.
Thank you, everybody.
Thank you.